Learn VR MR. Come to the Spatial XR community.
After opening the Unity project, we first click on File in the menu bar and then click Build Settings. The page that appears contains settings for packaging and publishing. We need to first select a platform for packaging. Here you can see that next to Windows, Mac, and Linux, there is a Unity logo, which indicates that by default, the packaging platform is for desktop computers. If we are developing a program to run on a computer, such as a PC VR game, we need to select the desktop platform for packaging. However, if we want to package the program for running on the Quest headset independently, we need to switch the packaging platform to Android, since the Quest system is based on Android. If we want our program to run on the Android system of the Quest headset, we need to package our program into an APK file, which can then be run on the Quest system. Later, I need to package this Unity program to run on the Quest. So I need to switch the packaging platform to Android. I click the Android tag here and then click Switch Platform. Now the platform switching process begins. After the switch is successful, you will see the Unity logo next to the Android tag, indicating that the current packaging platform is the Android system platform. We can now close the Build Settings window and proceed to import the Quest Development SDK. First, we click Edit in the Unity menu bar. Open Project Settings and find XR Plugin Management. Clicking Install here will install the XR Plugin Manager. After installation, the interface of XR Plugin Management will look like this. We need to specify the underlying plugins required by our program in this interface. When developing XR applications in Unity, the architecture involves two aspects. One is the underlying plugins, and the other is the higher-level interaction layer SDKs. The Meta XR SDK that I will introduce next is one type of high-level SDK for XR development. High-level SDKs are generally used to implement application-level functionalities. For example, if we want to grab a virtual object in a VR world, the high-level SDK can be used to determine whether the grabbing action has occurred. When the grabbing action happens, the object to be grabbed is attached to the object that initiated the grabbing interaction. We can grab with a controller or with gestures. So, to determine whether the grabbing action has occurred, we need to obtain input from the hardware devices. Controllers and gestures can both serve as inputs from hardware devices, but different hardware devices may have different input methods. For example, the button implementations on controllers of different headsets may vary, and gesture tracking algorithms may also differ. Therefore, if we want to adapt our interaction functions to specific hardware devices, we need to connect our program to the hardware-level interfaces so that the inputs from the hardware can be compatible with the interaction functions we want to implement. So, we need both high-level application interaction SDKs to achieve the corresponding interaction effects and underlying plugins to interface with different hardware platforms. This way, we can obtain inputs from the corresponding hardware devices and convert these inputs into specific interaction functions within the XR application. Now, let's return to XR Plugin Management. Here we can select different platforms. I am currently selecting the Android platform, and below it displays the underlying XR plugins for Android. There is a plugin providers section, and there is also an option for the desktop XR underlying plugin. Let's first click on the Android side. For developing Quest applications, we can choose Oculus or OpenXR for the underlying plugin. Choosing different options will result in some minor differences in the configuration steps later on. I will first select Oculus here. In the following lessons, I will mainly demonstrate using the Oculus underlying plugin, but we will also introduce the configuration method for using OpenXR as the underlying plugin in the future. This tutorial will focus on the configuration process with the Oculus underlying plugin. I will select Oculus on the Android side, and it will install the Oculus XR plugin. We need to wait for a moment. After the installation is successful, we will see Oculus in the lower part of XR plugin management. Let me first return to XR plugin management. We just set the underlying plugin for Android. Now I will click on the desktop side and select Oculus for the desktop as well. The reason for selecting the desktop underlying plugin is mainly to facilitate streaming debugging on the computer later on. What is streaming? Devices like Quest are standalone VR headsets, meaning the headset itself has its own chip and can run an XR program independently. In addition to running XR programs directly on the headset, we can also run XR programs on the computer through streaming. In this case, the computer's chip is responsible for the computation of the XR program. We can connect the headset to the computer via a USB cable or a Wi-Fi wireless network. After the connection is successful, we can stream the XR application running on the computer to the headset. In this scenario, the headset acts as a display to render the XR scene being rendered by the computer. This is the streaming approach. We can use the streaming method to conveniently debug our programs. When developing a project, it is inevitable that we will encounter some bugs or that the initial development results may not match our expectations. In such cases, as developers, we hope to have a convenient way to adjust the development results or to locate and troubleshoot errors in the program. If we run the XR program in streaming mode, we can directly click the Unity Run button to run the Unity program on the computer. With the headset connected to the computer, we can observe the XR scene running in Unity through the headset in streaming mode. We can use several panels in the Unity Editor interface to conveniently view the structure of the entire scene. For example, the hierarchy and scene panels allow us to see the position of each game object in the scene and their hierarchical structure. The inspector panel shows the components and scripts attached to a game object. We can adjust the parameters of these components or scripts while Unity is running to achieve the desired effect. There's also an important window in Unity called the console window, where we can view information output by the program and error messages. If our program encounters errors, we can check where the errors occur in this window, which helps us better troubleshoot the issues. If we were to package the program to run on the headset, each packaging process would take some time. If we had to package the program every time we made a small change, it would be very time-consuming for the entire development process, increasing the project's time cost unnecessarily. Moreover, once the program is packaged and run on the headset, we would not be able to use the windows and tools provided by the Unity editor to conveniently adjust the program's effects or troubleshoot bugs. Therefore, I recommend running the program in streaming mode during the development and debugging phase. Of course, it is also necessary to package the program to run on the headset for final testing, as the streaming effect may differ from the actual on-device testing effect. I will introduce the steps for on-device testing later. So, we need to select Oculus on the desktop side for the XR underlying plugin used during streaming. And we also need to select Oculus on the Android side for the underlying plugin used during actual device operation. Now, let's click on Oculus under XR Plugin Management. We mainly focus on the parameters under the Android and desktop sides, but the default settings are generally fine in most cases. One relatively common issue might be that during streaming, only one eye can render virtual objects, while the other eye cannot, or the entire rendered image may have some abnormal effects. In such cases, we can try to change the rendering mode on the desktop side to multipass. I have not encountered this issue yet, but I will explain it when it arises. Okay, this is something to note. During development, the shaders used for rendering game objects in the scene may not be compatible with the desktop settings in streaming mode. Therefore, we need to change the rendering mode from the default single-pass instance to multipass to resolve the issue I just described. Now that we have set up the underlying XR plugins, we need to import the high-level SDK for development, the Meta XR SDK. I will first close this window, click on Window in the Unity menu bar, and open Package Manager. Here, switch to My Assets, and the list will show the asset packages saved in your Unity asset library. We search for Meta in the search bar. Okay. And then we select the Meta XR All-in-One SDK and click Install to install this asset package into our Unity project. After successful installation, Unity will pop up a window, and we click Restart Editor to restart the Unity project. After restarting, Unity will pop up a window mainly explaining the updates to the hand skeleton in the interaction SDK from Meta. The hand skeleton is mainly used in gesture tracking interactions. We need to know the skeletal nodes on the hand and the names of each node so that we can track these hand joint nodes to achieve different gesture tracking interaction effects. We can also obtain the position and rotation data of the tracked hand joint nodes in Unity for further processing. In the past, Meta defined its own hand skeleton structure. But now Meta's SDK has been adapted to OpenXR, which has cross-platform characteristics. Therefore, Meta now recommends us to use the OpenXR hand skeleton, the hand skeleton structure defined in OpenXR. It also states that in versions v71 and above, the Interaction SDK will gradually deprecate the original OVR hand skeleton, and now it strongly recommends us to use the OpenXR hand for gesture tracking. So, we click Use OpenXR hand here. Then, we click In Project in the Package Manager, and we can see the Meta XR all-in-one SDK that we just imported. In fact, this SDK also imports other Meta XR SDKs it contains when imported. We can see that the Meta XR Interaction SDK has been imported into our project, as well as the Meta MR utility kit used for MR development. These are different Meta XR SDKs. Let's close the Package Manager window now. We click this button in Unity, which was added after we imported the Meta XR SDK. We click it and then click Project Setup Tool. It will automatically take us to the Meta XR section in the Project Settings window. This option was also added after we imported the Meta XR SDK. We can also manually click Edit in the Unity menu bar and then Project Settings to open this page. But we just chose to click Project Setup Tool here, which quickly takes us to the Meta XR page. In this page, we mainly click Fix All and Apply All on the desktop and Android sides. When you see all the options under the desktop and Android sides turn green, it means that the environmental configuration has been repaired. Then we close this window.